All right, here we go. Linear systems of equations, example 3. Once again, we can graph these two equations if we want. They would indeed be lines, two variables, both variables to the first power, line. Two variables, both variables to the first power, line. Two lines. Where do they cross in the night? All right, we're looking for that point of intersection. And as we've established, graphing is not really a very good idea here because, again, what if your lines are crooked? What if those numbers are decimals? It just wouldn't be easy to do that. So we have two methods that we've talked about. We have substitution, elimination. There is yet another one called matrices. But I would recommend on a two-variable system that will focus on the substitution and the elimination. And my hope would be that when you looked at this one, you said, look at that top equation. It's got a variable by itself, x equals. And if that's the case, in my opinion, and most other algebraists' opinion, couldn't we take that expression that's equal to x and go plug it in to the other one, into the other equation? Replace it, substitute. So I personally would think, and there's tons of ways to do things, guys, all right? But I got time to show you one thing. I would recommend we substitute that expression for x in that other equation. Here's your music trivia here. I'll play a little clip, see if you can figure out the band, and then I'll tell you the answer at the end. All right? So. Not very good sound quality, I get it. Anyway, the lyric, the reason I played this, substitution, mass confusion. All right? And I'll tell you who the band is at the end, if you care. So, all right. And hopefully I'll remember to do that. Okay, so we have 5 times, and then we put that expression in for x. That's why it's called substitution, because we are replacing a variable with an expression. And that bottom equation transforms into this when we make that replacement. And look at that, that's one variable now. So now we go back to our training for solving one variable equations. Assignment number 8. All right, and so okay, here we go, distribute. Now that's 5 over 1, isn't it? Okay, so that'd be 15 over 4. So I go, hey, brain calculator, what's 15 divided by 4? I sure hope it's a nice round decimal. And fortunately it is. 15 divided by 4 is 3.75y minus 5 times 4, that's 20, minus 2y equals negative 13. This is old stuff, assignment 8. All right, we can't reinvent the wheel every time. Sorry if I sound crabby old man, pants up to here. Combine like terms. That would be 1.75y minus 20 equals negative 13. Linear, first power. Hey, I'm a variable, you're a constant. You got to keep them separated. So that would be 1.75y equals 7. Divide. Divide by 1.75, divide by 1.75. And it looks like, in this case, y would equal, I believe, that's 4. All right? So there you go. And so there's that answer waiting to be filled in. Ordered pair, point of intersection, 4. Okay? So that's the value of y. Then the question becomes, we still need the value of x. I hope the picture illustrates that it doesn't matter which equation we put that 4 in, because it should give us the same value of x regardless of the one we choose. So there again, it's a coin flip, although I would recommend that we plug it into the one that says x equals, because we want to know what x equals. If fractions terrify you and you don't want to use this one, then use the other one. I don't care, okay? But I've always thought that if you want to know what x equals, you put the number into the x equals. So x equals 3/4 times 4, right, the value of y that we just discovered, minus 4, x equals, that's 4 over 1, arithmetic. Hey, the 4's cancel. 3 minus 4, arithmetic, -1. All right, hope I didn't make any mistakes when I downplayed, it's just arithmetic. So anyway, the value of x should equal -1 there. There's your ordered pair. That is the solution to that system of equations. And, you know, we'll just keep adding to the notes. What usually happens when you have two linear equations? They're going to cross at one point most of the time. Although you see 2 and 3, and you already see what they say. In class, I would put them up as they become relevant. But anyway, the typical occurrence when you have two lines is you have a single point of intersection, as that picture would illustrate. All right, so did anybody figure out who that band was? Did you ask, or did you know? I don't know. But anyway, that was a band called The Cars, and the song was called Bye Bye Love. And again, there's the lyric in there, substitution, mass confusion. But I hope for you, substitution is not mass confusion. All right, awesome.